A line has equation y is equal to mx minus 50 for some positive integer m. The line passes through the point a0 for some positive integer a. What is the sum of all possible values of m? Y is equal to mx minus 50, and they are saying that this is a point, so that means that when x is equal to a, y is equal to 0, and therefore if I isolate the 50, I get ma. And what do they want? They want the sum of all possible values of m. Okay, so let's first isolate for m. So m is equal to 50 over a. Now m is a positive integer, and a is also a positive integer, so that really helps us. So let's just make a little table here. Let's put a and m, and let's see what we get. Now, in order for m, if you look at this, in order for m to be an integer, 50 has to be divisible by a, right? So what possible values do we have? It's kind of a finite list. A could be 1. All the divisors of 50, basically, which I believe are 1, 2, 5, 10, 25, and 50, I think. Yeah, I think that covers it. Okay, so for each of these, a very simple calculation, calculate m. So it's going to be 50, 25, 10, 5, 2, and 1. And then they want you to find the sum, so add up those. So we got 75, 85, 90, 93. And that is the answer to this question. The integers 1, 2, 4, 5, 6, 9, 10, 11, 13 are to be placed in the circles and squares below with one number in each shape. Each integer must be used exactly once, and the integer in each circle must be equal to the sum of the integers in the two neighboring squares. If the integer x is placed in the leftmost square and the integer y is placed in the rightmost square, what is the largest possible of x plus y? So let's see what we can do here. Hopefully it'll not require too much trial and error. So let's see. Now the key in this question is this line right here. Largest. I guess that word is the key. Because there's a lot of ways perhaps to do this, but they're really concentrating on the largest. So okay, let's try this. So I really want the largest number. So the largest number is 13, right? So I'm going to start with 13. So let's put 13 here. Then the squares right beside it, this guy and this guy, the two neighboring squares, have to add up to 13. Okay, so I think I can do that with 11 and 2, but I want this guy to be as large as possible, so I'll put the 11 here and I'll put the 2 there. Right? So that's the technique. Okay, so I've taken up, I've used up 13, 11, and 2. Okay. So now let's go over and concentrate on that side. Again, same story. The next largest number I have is 10, so I'm going to put that here. Now I need two numbers that add up to 10, and I think 9 and 1 would be sufficient. Now I want this guy to be as large as possible, so I'm going to put the 9 here and the 1 there. And I think that should be it, but let's just complete this. Let's see. This guy here, if I put a 6 there, then the 4 would go there, right? Because 2 plus 4 is 6. And the only number remaining is 5, and that will match because 4 plus 1 is 5. So there you go. I've completed it. And we just wanted those two numbers, which represent the x and the y. And therefore, that's 11 plus 9, which is 20, being the answer to that question. In the diagram, ABC is a quarter circle centered at B. Each of the squares, PQRS, square SRTB, and square RUVT has side length 10. Points P and S are on AB, points T and V are on BC, and points Q and U are on the quarter circle. Line segment AC is drawn. 3 triangular regions are shaded as shown. What is the integer closest to the total area of the shaded regions? All right. So the first, let's see here. What's the first thing I should do here? Well, labeling it, that would help. So let's see. This will be 10. This will be 10. And, you know, I don't want to label it too much because it might get messy. And then, and then this region from A to P, that little guy there, I'm just going to call X. And same thing, V to C, it'll be X. And because of the symmetry of this diagram, the radius looks to me, it's always going to be 20 plus X, right? The distance from like B to C would be the radius of that circle. Well, it's a quarter circle. Okay. Well, where do I go next here? I think I'm going to need to know at least some value of X. I think that would be beneficial. So let's try to figure out what is the value of BQ, because that will give me the radius, the length of the radius, and I think that'll be the right step. So I'm basically trying to find the length from B to Q like that. Okay, well, that should be pretty straightforward with Pythagoras. It would be BT squared plus QT squared, right? Simple Pythagorean theorem, if I'm doing this properly. So that's going to be 10 squared and then 20 squared. So that's 400 plus 100, which is 500. And therefore, BQ, if you take the square root, would be square root of 500. And that is the radius. So going back to this guy, the root of 500 is the radius. So I put that in for r, and that's 20 plus x. And then when you solve for this, x is going to be, well, I mean, in terms of a decimal, using your calculator, 2.3606. I'm going to go to 4 decimal points to try to get it as accurate as possible. Okay, so now where do I go from here? And now I think what I need to do is find the equation of the line AC. That's going to allow me to figure out these points. It's that point right there, this point right here, that point right there, and this point. Those are very important because if I can get the coordinates of those points, then I'll be able to figure out the distances. And then I can just use 1/2 base times height to figure out the areas of those 3 triangles. Okay, so here we go. As always, the equation of any line is y equals mx plus b. And let's see here. The equation of that line, okay, well, one point on it would be, let's see here. Okay. I can use 0. This point A is 0 for x, and the A is the radius, which I believe was what, root 500? Yeah. So I can put that into here. So when x is 0, y is root 500, and therefore that means that b is root 500. Okay, so that helps. That means y is equal to mx plus root 500, and then I will substitute this point C. So C is what? Root 500, 0. Yeah, root 500, 0. That's the coordinates of that point, C. So when y is 0, x is root 500 m, like that. So solving this, we get m equal to, I believe, -1. Yeah, okay. That's very good. And now I can just go through and figure out these points. Okay, so let's keep that in the diagram. So my equation, therefore, is y is equal to minus x plus root 500 of that line AC. And therefore, that's going to help me figure out these points here. Okay, so, okay, how do I figure out these points? The first one, this guy right here, what do I need to plug in here? I think I got it. Yeah, so I already know the y coordinate is 20. And then that will help me figure out the x coordinate. Okay, I got it. So 20 goes there, minus x plus 500. And therefore, when I solve for this, let me just see if I did this right. 20 is equal to, yeah, so x would be root 5, yeah, x would be root 500 minus 20. And then when you do this math, you can use your calculator, of course. That will give a value of 2.30. That's, yeah, that thing. That the same as I got before. So let's just squeeze that in there, 2.36. Okay. All right. We need to, of course, figure out a few more. That guy right there. So that guy, let's see here. What am I going to use this time? I'm going to use x equal to 10 because I know that, yeah, x is, the x coordinate is 10, and then I'm going to figure out the y coordinate using this equation. So that's going to be y is equal to minus 10 plus root 500. And when I do this math, it's going to be 13.36. So put that there, 13.36. Okay, next one is this guy right here. And what should I use there? I'm going to use y. The y is 10. That's something I know from the graph. So let's figure that out. So again, using the same equation, y is 10, is equal to minus x plus 500, root 500. And therefore, when you solve for this, x will be root 500 minus 10. Sorry. This was a 2. I'm not sure why I put a 3 there. Sorry about that. That's a 12.36 because this is also 12.36. So I kind of looked at the symmetry there. Okay, and then finally this guy, I will use x equal to 20 there. So 20. And then that's going to be y is equal to minus 20 plus root 500. And therefore y comes out to be 2.36. 2.36. Okay. Now I'm ready to calculate the areas. So let's figure out the area of this guy first, that triangle. So that's going to be the first surface area. Oh, what am I? Surface area? Shaded area. SA, shaded area. Okay, so the first is 1/2 base times height. So the base from P to Q is 10, and this was 2.36. So you'd have to subtract from 10 2.36, and when you do, you get 7.6394 if you want to take it to 4 decimal points. And very similarly, QR is 10, but you'd have to subtract from it. Let me think about this for a second. Actually, all the way from top to bottom, Q to T is 20, and subtract from that this 12.36. Yeah, and then you'd get again 7.6394. Okay, so that takes care of that triangle. Then we add to that the little guy, this one right here. So that's again 1/2 base times height. Let's figure out the base and the height. The base, let's see here, 20. I forgot to fill this guy in. What was this guy? 12.36, right? Okay, so that means that little base there would be 12.36 minus 10, since BT is 10. So that's going to be 2.3606 if you want to take it to 4 decimal places. And similarly, the height, same kind of story. It would be 12.36 minus 10 if you look at it. So that's again going to give me 2.3606. Okay, then finally one last triangle, which is this guy. And it's very similar to the first one. It'll be the exact same, and I'll let you figure out how to do that. It's pretty straightforward. It's nothing new, and that's the numbers you're going to get. Crunch out these numbers, and you'll get 61.14, and they want the integer closest to that, which is 61, which would be the answer to this question. Karina is in a tournament in which no game can end in a tie. She continues to play games until she loses 2 games, at which point she is eliminated and plays no more games. The probability of Karina winning the first game is a half. After she wins a game, the probability of Karina winning the next game is 3/4. After she loses a game, the probability of Karina winning the next game is a third. Probability that Karina wins 3 games before being eliminated from the tournament is equal to A over B, where the fraction a over b is in lowest terms. What is the value of a plus b? All right, so game 1 and then game 2, probability of winning, probability of losing. So first, let's just fill in what this question is telling us. They're saying the probability of winning the first game is a half, right? So put a half right there. Now, if she wins, then the probability of winning the next game is 3 over 4, according to that part. If she loses, the probability of winning the next game is a quarter. So this is if she wins. Let me think about this for a second. The probability of winning the first game is a half, and then the probability of winning the next game is 3/4. I got it. Okay, so far we're filling in the table correctly, and if the probability of winning game 2 is 3 over 4, the probability of losing game 2 would be 1 over 4. So I'll just put that in there. Yeah, like that. So let me just cross that out. That might be a little confusing. Okay, so that's fine. Now we'll talk about the probability of losing. After she loses a game, so if the probability of winning is a half, the probability of losing is a half, right? Because that's got to add up to 1. Okay, so that's a half. If she loses, the probability of winning the next game is a third. Okay, so a third goes here, and that's the probability of winning the next game. And therefore, the complement, which would be 2 over 3, would be the probability of losing. Okay, so this is correct. 1/2, 3/4, 1/4, 1/2, 1/3, 2/3. Okay, great. So now that we have that, we have to figure this out. The probability that Karina wins 3 games before being eliminated. Okay, so she's eliminated if she loses 2. So the 2 losses could come at the very end. So they could be like this. Or the second loss has to be the 5th game. Let me think about that. Yeah, because that's the only way you could have 3 wins and 2 losses, according to the rules of the question. So, but the first loss could be like that. It could be shifted a little bit. So, like this. So it could be the second game or the first game. So I think these are the only scenarios that match. Yeah, I'm pretty sure about that. Okay, so now we got to use these numbers here to figure out these scenarios. Now, I'm going to be honest with you. When I first calculated this question, I got at the very end an answer of 11 over 128 for a over b. Now they want a plus b, so I said, okay, that's not a problem. That's 139. But that is a problem because all the answers to these questions from 21 to 25 of this contest have to be 2-digit numbers. This is not a 2-digit number. So I thought, well, what did I do wrong? What I did wrong, I thought about this a long time. What they're saying in the official solutions is that you don't calculate the full probability of this whole thing. You only need to calculate the probability of this guy. And then for the second scenario, just the probability of that much. For the third scenario, just the probability of that much. And for the fourth scenario, just the probability of that much. Because they're saying that is what's being asked, the probability that Karina wins 3 games before being eliminated from the tournament. You see what I'm saying? I mean, I don't know if I agree with that, but hey, that's what the official solutions are saying, so I guess we go with the official solutions. Right? Whatever. Okay, so let's calculate that. So the first one, WWW, probability of winning, let's just put a little label here, 1, 2, 3, 4. Probability of winning the first one is a half. And then after winning the first one, the probability of winning the second one is 3 over 4. And then the probability of winning the third is again 3 over 4. I'm getting those numbers directly from here. Directly from here. And then, of course, you have to multiply them all to get the full probability of that scenario, WWW. And when you do, this is 3 over 32. Yeah. Okay, number 2. Again, probability of winning the first one is a half. If you win the first one, the probability of winning the second one is 3/4. If you win a game, the probability of losing is 1 over 4. If you lose, the probability of winning the next one is 1 over 3 from this table. So that goes here. And let me just double check if I did this right. 1/2, 3 over 4, 1 over 4, and 1 over 3. Yes. So when you multiply it out, it gets 3 over 16 times 6, which is 96. Got it? Hopefully you're getting the hang of this. Number 3, win. Probability of winning is a half. If you win, the probability of losing the next one is 1/4. If you lose, the probability of winning the next one is 1/3. And if you win, the probability of winning the next one is 3 over 4. So this is 3 over, same thing, right? 96? Yeah, 3 over 96. And then finally, number 4, probability of losing is a half. If you lose, the probability of winning is 1 over 3. If you win, the probability of winning again is 3 over 4. And if you win, the probability of winning again is 3 over 4. So this is 9 over 96, I believe. Okay, so now the whole thing has to be added. So when you do this, let's just put this over 96. So that's going to be 9 over 96. So this will be 9 plus 3, 12. 12 plus 12. Wait, one second. I think I did this. Sorry. I know you guys are probably figured this out before. This is not a 3. This is a 9. And therefore, this is a 27. Sorry about that. Okay, let's add this again. So 30, 33, 42. 42 over 96. Okay, now we got to make this into lowest terms because they wanted it in lowest terms. So what are we going to divide by? 6, I think. So it'll be 7 over 16. And this is a over b. And therefore a plus b will be 7 over 16. Sorry, 7 plus 16, which is 23. And 23 is the 2-digit number that is the answer to this question. A set consists of 5 different odd positive integers, each greater than 2. When these 5 integers are multiplied together, their product is a 5-digit integer of the form AB, 0AB, where A and B are digits. A is not equal to 0 and A is not equal to B. The hundredths digit of the product is 0. For example, the integers in the set 3, 5, 7, 13, 33 has a product of 45045. In total, how many different sets of 5 different odd positive integers have these properties? Okay, so we have A, B, C, D, and E, and it's a product, so multiplied together. And they're saying that when you multiply those together, you get a product A, B, O, A, B, and these are the digits of that 5-digit number. And A is not equal to 0, and A is not equal to B. Okay. So our number, we'll call it n, and it's equal to AB, 0, AB. Now, n could be factored as 1001 times AB. So, for example, if you had, let's say if AB was 2, 6, then the number would be 26026, which is the equivalent of 1001 times 26. Yeah. So that's how you get this factorization. And then you can write this as 1001 times AB. I'm going to call it T, where T is equal to AB. And then what I'm going to do is further factor that 1001, which I believe is 7 times 11 times 13, and then that T. Okay, so that is the beginning, and now we got to figure out all the different scenarios, and that's very, unfortunately, time-consuming, so just bear with me on this one. And also, different sets, so they want unique sets, because there's going to be some doubles. Like if you'll get the same thing again in another set, so you can't include it twice. You have to just choose unique sets, so that's another challenge to this question. Okay, let's go through it. So first case scenario, my set, obviously, I can use this as sort of a very important starting point. If I want 5 numbers that are going to be multiplied together to give that, I can choose those 5 numbers to be 7, 11, 13, and something else. Now, I don't know what those others are, so I'll just call them M and N. And I'll write them as M less than N, like that. Okay, so then N would basically be 7 times 11 times 13 times M times N, correct? And which is 1001 Mn. Now, it has to be a 5-digit number. So the largest 5-digit number is 9999, and then, right, the largest N can be. And we have to incorporate that 101. So when I divide by 101, what's left over is about 99.9. So that basically means that this Mn has to be less than that 99.9. That's beneficial for us to know because it kind of limits our choices. So this Mn, which is basically our T from up here, is going to be less than 99.9. Okay, so let's go through this. Now, these numbers are odd, right? Odd positive integers, each greater than 2. So let's start off with the smallest odd positive integer greater than 2, which is 3. If m is 3, what do we get? Well, then n, according to this, there's a lot of choices. It could be 5, 9, 15, 17, 19, 21, 23, 25, 27, 29, and 31. So, and I specifically put just the ones that do not give, that do not fail the criteria, because the criteria that needs to be matched, like this criteria needs to be matched, or that criteria needs to be upheld, because you can't have A equal to B and, that kind of stuff. Now let's keep going. How about if m equals 5? That means n equals 9, 15, 17, and 19. Again, you might say, well, why did you skip over 11 and 13? Because 11 and 13 are already here, and I can't use them again. They're distinct numbers. See, a set of 5 different odd positive integers. You see what I mean? So that has to be carefully looked at. And I think that's it. Yeah, I think that's it. Because the next one would be 7. You can't use m equals 7 because 7's already here. And if you use 9, you would get, I think, a possible value of n to be 11, but you can't use 11 because 11's already been used. So this exhausts actually everything. So let's count all these. These give me, I believe, 15 cases. So that is part of our total, grand total. Okay, if that's just the first scenario. We have a few more other scenarios, actually. The other scenario is if you have 7, a multiple of 7. So I'll put 7q, 11, and then 13, and then, again, this m in the end. And this time, when you multiply it, you'd get 7q times 11 times 13 times m times n. and that is basically 1001 times mn and then this q. Now it's a little bit different, right? But again, as we talked about here, we have parameters that m and q have got to be less than 99.9. Yeah. Okay, so again, let's go through this. Now we have 3 to worry about. Yeah. Okay, so let's go through this. So how about if I try q? I can't use 1 because that obviously doesn't make a multiple of 7. I can't use 2 because that would make it 14. 14 is even. But I can do 3. If q is 3, that means mn has got to be less than 33. And therefore m can be 3, n can be 5, and 9. Can't make a 7 because 7's already up here. Well, actually, if you use 7, let's see here. Yeah, I believe when you use n equals 7, you get a case that's already used up here. So if I use n equals 7, it would be, with q equals 3, it would be 21, 11, 13, 3, and 7. But that's already used up here, right? 7, 11, 13 is the standard. And then mn, 3 and 21, 3 and 21. You see how that would be a double count? So that can't, that's why n can't be 7. So it's quite challenging, actually, to come up with unique ones. Okay, let's keep going here. When q is 5, by the same sort of principle, we have mn less than 99 over 5, whatever that works out to. And therefore, when m is 3, and then n is 5, and that's the only one that I can use, meeting all the criteria and making sure that I don't have overcounts. So how many did I get for this guy? I got 1, 2, 3. So I got 3 here. Unique ones. Okay. Pretty decent so far, I think. Okay, let's keep going. Hopefully we can finish this off. So the next one is if you have 7 and then you have a multiple of 11 and then 13 in m and n. So again, n is going to be 1001 mnq by the same sort of philosophy. And this time the mnq, same thing, is less than 99.9. And let's again start with q equals 3. If that's the case, m will be 3 and n therefore will be 5 and 9. And if q is 5, if m will be 3, n will be 5, and then that sort of is the only ones that will ensure that the rules are followed and that you don't get any overcounts. So that's another 3 that I got. 1, 2, 3, like that. And then there is, I think, just one more scenario, and that is, that will, give us unique cases, and that is if you have 7, 11, and 13, a multiple of 13, m and n like that. So same thing, n will be 1001 mnq, and then mnq again less than 99.9. And if q is 3, m will be 3, n will be 5 and 9. And if q is 5, m will be 3, and n will be 5. These are the only, again, 3 cases. So again, we have 3 here. And this exhausts all the possibilities. Otherwise, if you go further, you'll get cases that either are already done, so you get overcounts, or you get scenarios that don't match the criteria, where the criteria, for example, this criteria. Okay, so we have 15, 3, 3, and 3. So 15 plus 3 plus 3 plus 3, and that's 24. And 24 is the answer to this question.